Today we're going to talk about multi-step inequalities. So we've looked at graphing them, writing the solutions in interval notation, solving 1 and 2 step. So now we're going to go to multi-step inequalities. So there's a warm-up on the top of your notes. Go ahead and do that. Pause, and when you're ready, go ahead and move on. If you have any questions, make sure that you save them for me in class. Okay, so what are you going to learn today? Today you're going to learn how to solve a multi-step inequality, and we're actually also going to do some word problems. I know that you guys love to do that, so we're going to do 2 word problems as well. Right. So how do I solve inequalities? The first thing that I do is I get rid of any grouping symbols that I might have by distributing. If I have like terms, things that I can combine on one side or on the same side, I go ahead and combine them. And then I move the variables to one side and numbers to the other by using inverse operations. So I'm either going to add or subtract. And then I undo multiplication and division using the inverse. So again, these are just exactly like solving an equation, except that when you multiply or divide by a negative, you got to flip the order symbol. So let's go ahead and solve this. I've got the x's on the one side that I can combine. So I can combine these, and I'm going to get 7 is greater than or equal to negative 7x. Okay, if I divide by negative 7, I get negative 1, and since I divided by a negative, I got to flip the order sign. Okay, and then there are those of you that like the variable on the left. So when I flip the variable, I flip the order sign. So x is greater than or equal to negative 1. The other way I can write that in interval notation would be negative 1 to positive infinity. If I graph, okay, I'm going to have a closed circle on negative 1, so closed circle there, and my arrow will go to the right. Let's do another example. Again, I have like terms on one side, so I can combine my x's. Remember to take the symbol in front. So that's like negative 3x minus 1x, which is negative 4x. So I'm going to get 2 minus 4x is less than negative 18. Okay. I'm then going to subtract 2 from both sides. I've got this negative that stays with that, or that subtraction, and it becomes negative 4x is less than negative 20. When I divide by negative 4, I've divided both sides, so I'm going to flip my order sign, and x is greater than 5. Okay, in interval notation, parentheses, because the 5 isn't included, to positive infinity. If I'm going to graph, I'm going to have a closed circle or an open circle on 5. And again, my arrow is going to go to the right. So open circle and to the right. Okay. Next, this one's a little more complicated. I kind of picked things that I knew you guys had trouble with from equations. So remember, we're distributing a negative. So we're distributing this negative 7. So I'm going to get 200 is greater than negative 35k minus and positive is plus a negative 7 minus 3. Okay. Now I can combine negative 7 and negative 3, so I get 200 is greater than negative 35k. Since it's negative 10, I'm going to just say subtract 10. I'm going to move the 10 to the other side by adding 10. I'm going to get 210 is greater than negative 35k. I'm going to divide both sides by negative 35. Since I've divided by a negative, I'm going to flip the order symbol. So I'm going to get 6 is less than k, or k is greater than 6. In interval notation, it's not included, so 6 to positive infinity. When I go to graph, I'm going to have an open circle on 6, and my arrow is going to go to the right again. Seems I like those greater thans. So that's going to go to the right. So anything that's larger than 6 is part of the solution set. Next example. This time I'm going to distribute my 8 here and here. So 8 times 4 is 32. So I have 32p minus 24 plus 8p is greater than 216. Combine my p's. 32 and 8 is 40. So I get 40p minus 24 is greater than, that should be equal to, you can barely see it, or equal to 216. If I add 24 to both sides, I'm going to get 40p is greater than or equal to 240. And now if I divide by 40, so I'm dividing by a positive so I don't flip the sign. So p is greater than or equal to 6. So this time with my interval notation, it's going to be a bracket because 6 is included and then off to positive infinity. Now we get a little trickier because we've got two things we're going to distribute. I'm going to distribute the 2 just to the 6 and the 3r. So I'm going to get 12 plus 6r. And this negative 2 goes here into 3. So I get minus 6r minus 6 is greater than negative 9. If I combine my like terms, 6r minus 6r cancels out. So I'm left with 12 minus 6 is greater than negative 9. And then 4 is greater than, or sorry, 6 is greater than negative 9. Now think back to when we studied equations. Whenever we had a statement that was false, it meant that there's no solution. Whenever we have a statement that's true, it means it's all real numbers. So 6 is always greater than negative 9, so our solution would be all real numbers. And in interval notation, that's just negative infinity to infinity. All right, so enough of just the bare problems. Let's take a look at a word problem. So 3/4 of a number decreased by 9 is at least 42. Okay, so 3/4 of a number, so we don't know what n is. And 3/4 of it means to multiply. So 3/4 n. Decreased means subtraction. So decreased by 9 is at least. Okay, so it's at least. I'm going to have more than that. So we're going to say greater than. So at least, or equal to, is always greater than or equal to. At most would mean we couldn't have any more than that, so that would be less than or equal to. So this is at least 42. So then it just becomes a two-step problem. If I add 9, I'm going to get 3/4 n is greater than or equal to 51. I can multiply both sides by 4/3. So n is greater than or equal to, I'm going to rate this over 1. Okay, and 3 goes into 51 17 times. So it's 17 times 4, which is going to be, because these cancel, n is greater than or equal to 68. So there's my solution. Okay. One last problem. Benito has $6 to spend, and a sundae costs $3.25 plus 65 cents per topping. Write and solve an inequality to find out how many toppings he can have on his sundae. So let's let t toppings. Okay. We know that he has $6 to spend, so he can't spend any more than that. So whatever he has, it's got to be less than or equal to 6. The sundae is $3.25 plus, so we're going to add 65 cents per topping. Remember, per means to multiply. So 0 and 65 hundredths times t. So now again, if I subtract $3.25 from 6, I'm going to get 65 hundredths t is less than or equal to 2.75 or $2.75. And if I divide by 65 hundredths, then t is going to be less than 4.23. All right. So because he can't go over that, we're going to go with the lower number. So we're going to round down, and he can get 4 toppings. Okay, 5 would put him over the edge, but so he'll get a little bit of change back. All right, so today we looked at how to solve a multi-step inequality and how to solve real-world inequality. Okay, have a great evening. I'll see you in class tomorrow.